You can assign variable coordinates to the vertices of quadrilaterals. Then you can use the distance, slope, and midpoint formulas to write coordinate proofs of theorems. Write a coordinate proof for the following statement. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So the first thing we're going to do is we're going to position this hypothetical quadrilateral on the coordinate plane. And we're going to use the origin as one of our points. That's the easiest point to use, so we want to make sure that we put that in there. We're going to call this quadrilateral ABCD on the coordinate plane, and we're going to position it in such a way that segment AB is parallel to segment DC, and segment AB is congruent to segment CD. So we're going to call AB the length of A. We're going to put A at 0, 0. We're going to put B at the imaginary point A, 0. And then we're going to position D and C on the coordinate plane as well, so that they are however far over and C units up. And we're going to call the distance over B, and we're going to call this distance over B plus A. Because remember, A is this entire distance here, and we want them to be congruent. So this distance has to be A, and we're calling this extra one here B. So this distance will be all of A plus B, a little bit more. So we have our coordinates. Point D is at BC, point C is at B plus AC, A is at 0, 0, and B is at A, 0. So we're going to use those coordinates to write our proof. Okay, so we have forced our quadrilateral onto the coordinate plane, and we have forced AB to be the same length as DC, and they are parallel to each other, and we're going to prove both of those things right now. So the first thing we're going to do is we're going to use the slope formula to prove that they have the same slope, to prove that they are parallel to each other. By definition, a quadrilateral is a parallelogram if opposite sides are parallel. We are given that AB is parallel to DC, so we need to show that AD is parallel to BC. So we're going to use the slope formula, and we're going to plug in the points for A and for D. So A is at the point 0, 0, and D is at the point BC, which gives us a slope of up C over B. And then we do the same thing for BC, proving that it is up C over B. So therefore they have the same slope. Now, because AD and BC have the same slope, AD is parallel to BC. So quadrilateral ABCD is a parallelogram because opposite sides are parallel. This is parallel to this, and this is parallel to this.